The Soviet spacecraft Soyuz MS-12 was launched on September 27, 1973, and was notable for being part of the Soyuz program, a series of missions intended primarily for crew transport to and from space, especially to the Soyuz space stations. Here is a detailed analysis regarding its Earth-to-orbit trajectory, mission objective, and overall context within the Soyuz series. Launch and mission profile. Soyuz MS-12 was launched aboard a Soyuz rocket, which is reliable multi-stage launch vehicle designed specifically for crew missions. The version used for Soyuz 12 was likely the Soyuz U, a common variant of the Soyuz rocket that has been used for many launches. The launch took place from the Baikonur Cosmodrome in Kazakhstan, which has been the primary launch site for Soyuz missions since the early days of space exploration. The primary objective of Soyuz 12 was to test the capability of Soyuz spacecraft and carry out a crew mission to the Soyuz 7 space station. Other objectives included testing life support systems and assessing crew performance in orbit. Following liftoff, the Soyuz rocket ascends vertically, gaining altitude while progressively increasing speed. The vehicle passes through various phases in the atmosphere, known as vertical ascent phase. Aerodynamic forces are most significant here, and careful engineering minimizes stress in the spacecraft. The Soyuz rocket consists of multiple stages. After the initial phase, the first stage burns out and detaches, followed by igniting the second stage. Each stage is designed to drop away once its fuel is expended, reducing weighting and allowing the remaining stage to accelerate further. After the final stage burnout, the spacecraft reaches a suborbital trajectory and eventually enters into a low Earth orbit. The velocity required to maintain a stable low Earth orbit is approximately 28,000 km per hour or 17,500 miles per hour. At its operational orbit, Soyuz 12 would have achieved altitude that typically range between 180 to 420 kilometers, about 102 to 261 miles above the Earth. The specifics of the orbit would depend on the mission's requirements relating to the Soyuz station's position. Once in orbit, the spacecraft performs functions such as adjusting altitude and orbital parameters, which are crucial for rendezvous with the Soyuz space station. Soyuz missions usually involve docking with target stations, which require precise navigation and timing. The spacecraft is equipped with automated systems and in some cases manual control for the docking procedure. Soyuz 12 had an operational period that lasted approximately 7 days, during which the crew conducted various activities, in some cases including scientific experiments, system checks, and preparing for re-entry. At the end of the mission, Soyuz 12 executed a re-entry sequence which included entering the Earth's atmosphere at a high velocity. The spacecraft uses heat shield to protect against the intense heat generated during re-entry. Parachutes were deployed for a controlled descent, ultimately leading to landing. Technological development. The Soyuz 12 mission was critical for testing the capability and reliability of the Soyuz spacecraft system. Modification and improvements made based on the experience gained during this mission contributed to the overall success of subsequent missions. Soyuz spacecraft become the workhorse of crew transportation to space stations, supporting the Soviet Union's ambitions in human spaceflight and later serving international collaborations such as the International Space Station mission in the 21st century. The achievements and lessons learned from the Soyuz mission, including Soyuz 12, have influenced space missions globally and helped maintain the presence of humans in low Earth orbit for decades. Soyuz 12 was an essential mission that demonstrated the ability and capability of Soyuz spacecraft in achieving its objective. The trajectory from Earth to orbit encapsulated sophisticated engineering, strategic mission planning, and contributed to the broader narrative of human space exploration during a critical period of technological advancement in the 20th century. Kindly follow us for more space updates. Subscribe, like, comment, and share.